Hello, I'm Larry Weingarten. I like water heaters. I'm here to share with you what I know about how to troubleshoot water heaters, how to maintain them, make them last, how to deal with problems as they come up. I've been involved in hot water for a long time. I collect old water heaters, got a nice collection. Old heaters are full of interesting ideas that I think we can use today. Years ago I wrote a book, the Water Heater Workbook, on how to maintain water heaters and install them. I'm involved in a website, waterheaterrescue.com, where we answer literally thousands of questions from people all over the world about how to deal with their water heater problems. But what I'd like to do now is go and have a look at first a gas water heater that's having some problems. We'll troubleshoot it. Others have looked at it and they can't make it behave, so let's see if we can. And then we'll go look at an electric water heater. So come on up, let's see what we can do. Okay, so here's the device. So the flame's coming out, but it's weak, and it clearly has put a little soot on that, but isn't really hitting it much. I also see some soot on the bottom of the burner itself and debris on the top of it. So want to clean this whole thing up. Always start fine threaded things by hand. Use tools on them to get them snug, but if you cross thread pieces with tools, you will ruin it. And that's sad. So don't want to ruin much. Okay, now I'm going to insert the thermocouple. As far as it goes, you can see there's a little spring clip and even some ridges there that hold it to keep it from falling out. Here are the pieces for the burner pilot tube thermocouple. Just to recap, the way that this thing works, the burner isn't going to come on unless the gas control tells it to or sends gas to it. That's not going to happen unless gas is already coming down the pilot. There's a flame there that you've lit with a match. The flame then is heating up this thermocouple. The thermocouple generates less than a volt, but that's enough energy to power the gas control so that then when you turn it on, it stays on and allows gas to get to the main burner. It's a safety device. If this were not working and this came on, you could have a lot of gas escaping into it without a pilot flame there to light it. So that's why this sequential approach has been figured out. And there you can see we have nice blue flames, a little bit of yellow tips, but that's typical of propane. Also, this hasn't run for a while, so there is a fair amount of dust on it that's going to have to burn off. As long as we're up here, I'd like you to look at the top of the anode rod, right down here. See, when they build the tank, they have a plastic coating that goes on top before they inject the foam. This anode still has the plastic on it, which tells you in a very certain way that the anode's never been checked. When it gets easy on that side, I can cheat and speed things up. When you get close to the end, you want to listen. Hear a little hissing sound is actually air getting sucked in. That's good. If we saw water coming out here or didn't hear that hissing sound, that sucking sound, stop, because the thing is going to shoot water out and this anode's going to take off like a rocket with water pressure. That's a bad thing. But this is doing fine. Now it's not, I've got it loose, but it's not coming out. So I have a pocket knife trick. Swiss Army pocket knife trick. There's corrosion around there, which I'm getting rid of. Fair amount, actually. You can hear the sort of mushiness on the rod. Okay. I think we need to compare this to a new rod so you get an idea that it actually was time to replace this. Okay, let me hold up the new rod. There you go. This new rod is what the old rod used to look like. You're supposed to replace them when only 6 inches of this core wire is visible. So we're a little late. Still, we'll go ahead and replace it because this is what makes heaters live. This corrodes away slowly, producing a little bit of electrical current, just about 0.8 of a volt, and it prevents the rusting or prevents the steel tank from being able to rust. I've had tanks live over 50 years replacing these rods. We're here in Carmel Valley, Central California coast, to look at a water heater. We're out in the sticks, as you can tell looking behind me. This is an electric water heater. A lot of things wrong with it. It's an old heater. It wasn't heating correctly. So we'll see how to troubleshoot an electric heater, how to look at it, and what we can do to make it better. See you down there. Back to this element. If this is sticking in the water heater and we're looking to find out what's wrong, all you see is the head of the thing. You can't really tell by looking at it that anything's bad. Sometimes when these fail, this sheath actually splits. You see sort of like a little fish mouth open up in it and you can see something wrong, but not always. This element is no good, but you can't tell it by looking. So one of the settings on this is ohms. Over on the green side here, you have an ohms times 100. You have ohms times 110 or 100. If I touch these together, it's just checking for continuity, and you can tell, okay, this is why I like the old-fashioned analog type meter. So if I check this element, it's ohms times 100. If there were any continuity there, that needle would be swinging over. So this is telling me that the wire inside of this element's broken. Electricity has no way it can flow through it, so it doesn't heat. So when this thermostat says, oh, I'm warm, I'm at 120 degrees, it switches and shunts power down to the lower thermostat. That one then says, oh, water down here is cold, so I'm going to send power to the lower element. When it gets up to 120 or whatever you've set it for, then that one's satisfied, and the power is, both thermostats are now turned off, and the tank is simply full of hot water. Both thermostats should be set to the same spot. These currently are set to 120. From an energy point of view, that's good. From a bacteria point of view, I actually like 130 or even higher. ASHRAE is suggesting 140. We're worried about Legionnaire's disease. If you have real old, real young people, anyone with immune system problems, a little hotter is better. We are in my water heater museum with Shadow. He's come to help. Actually, we're here not so much to look at old pictures or old water heaters, but to have a look at a new water heater, this cutaway one, so we can better understand what goes on inside of a water heater and how they work, what you can do to make them better, how to make them last. Shadow's really interested in this. He is. I'm going to start. This is the inside of a water heater. This is a new heater that I cut away some years ago. This shows you pretty well what I feel a heater should look like. You can see this sort of grayish, bluish coating as a glass lining on it. It's a steel tank. This is you can see fairly thin steel. And then this has 2 inches of insulation, foam insulation. and a steel jacket. Other pieces of the heater, this thing is a sacrificial anode rod. It corrodes away so that the steel of the tank cannot rust. This pipe here is called a dip tube. It delivers cold water down to the bottom of the tank. I've serviced about 4,000 water heaters, and I always check temperature and pressure relief valves. Of those, about 1 in 4 doesn't pass the test. The test on a relief valve is simply hold the valve, open the lever up, let it flop shut. If it lets water out, that's good. If it shuts off when you're done, that's good. Some don't let water out and some don't quit running after you've tested them. Now, of those that I test, of the failed ones, about 1 out of 10 of those is plugged up solid, just like this guy is. So that's not a safe, that means in my area, central coastal California, about 1 out of 40 heaters has no protection from the temperature pressure relief valve. We're going to cut away to some video that Watts did in 1942 showing what happens to water heaters when there's no protection.
Explosion danger lurks in thousands of typical hot water heater installations because the great majority have either improper protection or no protection at all. Hard to realize that an overheated tank can be dangerous, but 30 gallons of superheated water can explode with violence, causing destruction. The tank landed over 500 feet away.
Water heaters are an interesting beast. They are really very simple in construction, but they're complex in the way things can go wrong. It's good. Okay, you. That's it. We're done. Can you hear the purring? Oh, good.